Hi, everyone. So today's guest is Professor Mike Bonsall. He's a professor of mathematical biology at the University of Oxford. He's a senior research fellow at St. Peter's College and head of Mathematical Ecology Research Group, where mathematics meet ecology, evolution, health, and economics in ways that consistently produce surprising results. And his recent work sits as a fascinating intersection, using mathematical modeling to understand, how the brain processes overwhelming experience and, what that reveals about the mind's capacity to restore itself. One result from that work stands out. A single guided online session teaching a mental rotation process left 70% of participants free of intrusive memories at 6 months, published in Lancet Psychiatry. So, we are extremely honored to have him here. So, Michael, can you tell me a little bit about your background, like what got you interested in this field and,
Yeah, sure.
you are so deep into it?
Yeah, deep into it now, basically. It's such a long time ago how I got into this. So, yeah, thanks for hosting me, but it's just, it's a long journey. I think actually I loved, maths and biology at school, interested in natural history. So ended up going to London to do my degree, fell in love with biology, thought it was really cool. And then during one of my classes there, got introduced to this idea of something called ecology, which I'd never heard of. And this idea that you could use maths to understand ecology. And I said I love maths and bio at school. So I just got really, I thought, this is it. This is where I want to be. And then from that, everything else spun out of it, basically. So I did my PhD at Imperial College in London. And then about 20 years ago, moved to Oxford. So as you said, I'm in the biology department now. But being able to blend maths and biology together has just been super interesting. A super journey as well, actually. Super interesting journey. So as I said, I started off as in doing environmental biology, but most recently, we've the cool thing about maths is that it opens many doors for us, and we can just run down different rabbit holes of sort of different things that are interesting, and we can apply those maths to these sorts of questions around mental health and sort of neurodynamics, which is pretty cool.
Yeah, fascinating. To be able to be brilliant in mathematics and biology at the same time. That's like using both sides of your brain,
Certain
right?
parts of my
That's
brain,
amazing.
all the time, basically. It's super cool.
Yeah, so you're exactly the right person to talk about it. So I would love to start at the beginning, like not the CV version, but the actual moment. Like when did you first realize the questions you were asking about biology and mathematics were pointing somewhere genuinely surprising? I know you had interest in both the fields, but like which was the moment when you started realizing, okay, these are creating results, like
Yeah,
the
yeah.
direction you're thinking?
Yeah, so as I said, during my degree, I learned that you could do these things. It wasn't until I got to my PhD that I actually could start to think about putting sort of bits of the biology and the bits of maths together. And after that, I just, as I moved to Oxford to set up the group, I really wanted to be at this interface between biology and so that gave me so being in a biology department with lots of sort of colleagues around that did very cool biology and not just that different from my own, just got into sort of thinking about, oh, that's an interesting problem. All right, let's see if we can think about that mathematically and how that might help. So then in this space, in this sort of thinking about the sort of neurodynamic space and sort of mental health space, it was really just thinking about bringing all of those skills that I'd learned during my PhD into the same sort of space in the sort of psychology and psychiatry space. So really thinking that actually these could be quite applicable and give us some pretty nice ways of being able to understand sort of how the brain works, how things change over time. And that's what we're super interested in, is that how do things change over time? And we can delve more into that if you want, that whatever that actually means. But it was that just then I thought that I got excited about this during my degree and my PhD, and then as I moved to Oxford, this is what I want to do, basically. So yeah, that's what I'm doing, living the dream.
Yeah, fascinating. So the work on mental imagery and memory, how did that begin for
Yeah, that
you?
was very cool. One of those very serendipitous moments, actually. It was with Emily Holmes, the person I work a lot with on this.
Yeah.
We were chatting. We'd known each other for a while, and not about, but we were just chatting about work. And Emily goes, she asked me if I knew anything about time series analysis, and that might sound a little bit esoteric, but it's about how things change through time and how we approach that analysis statistically. And that's one of the things I sort of learned to do during my PhD, sort of thinking about how we sort of, I just said, oh, what have you got? I said, oh, we've got this mood data. I'd never, what is that? And it's just it's people can sort of like take their mobile phones and sort of like record how on a scoring system how they feel, and they do that over time. So we just opened that up and opened up that sort of questions, and it sort of like ran us down sort of, sort of like avenues of exploration statistically, in that sense of really thinking about how can we understand people, the way that people feel in that sense. So with all these sort of the standard scoring systems, principally in patients with bipolar disorder, but sort of like it works in many different ways, and we're sort of able to sort of like approach that and understand how moods might fluctuate. These were recorded on a weekly basis, but that might be so just from one week to the next would be quite important if you're suffering with something like bipolar disorder. So to being able to understand, the ups and downs of those sorts of mood fluctuations was something that sort of like sparked that interest into this sort of space. So but yeah, it was just that sort of like, again, all of that sort of like baggage I brought from my PhD was able to sort of like land it in this sort of space. And it's very, very, very interesting. And then we've sort of like developed that out in many different ways over the last sort of like 10, 15 years that we've been working on this.
Fascinating. So let's go into the mechanism. The imagery competition hypothesis says that the brain's visual-spatial resources are finite and shared. A visually demanding task can essentially outcompete the formation of a traumatic memory, right?
Yeah.
How did you arrive at that model, and what does it tell us about the brain's manages, how the brain manages overwhelming experience more generally?
Yeah, so it's sort of in your question. It's sort of in the question in that sense. There's a finite space. There's only a finite amount of space in our heads. It's taken up with a lot of grey matter. There's a lot of it, but it's still is limited in that, and we have to share. It has to be shared in that sense. It's got to be shared amongst a whole set of different sort of like processes in that sense. So thinking actually, if you have how you, and we may get into this in the conversation, so actually thinking that we are a visual species in that sense. We've got a very big, enlarged visual cortex at the back of our brains. It's very different to many other organisms, even our closest relatives in that sense. Our visual sort of like machinery within our brains is super, super active in that sense, and been lots of resource put into it. So we put more finite bits of that resource into visual stuff. And then thinking of sort of like this imagery competing hypothesis, then you've actually think, well, actually, how many images can you hold in your mind at any one time? I can manage about 2. Then maybe there are people that could do more. But it's like, how do you imagine? How can you, bring to mind, an elephant and a car and a bar and all of those things simultaneously in your mind, actually? And it becomes quite a hard task to do. So then they are competing for that space. They compete for that, what we call working memory. They're competing for that stuff that we're using, all the, in terms of activity within our brains, and there's only a finite space for it. So taking that idea that there's only a small amount of space, and that you can only there's only like a finite amount of space to hold these images in. Okay, and could you devise then a way in which we can compete? Let's call them neutral memories with more traumatic memories, and what might the outcome be in that sense? So the things with memories is that they're not a single thing. If you think about a memory, actually it has many components to it, and we call in the neurodynamic world, with sort of like in the psychology world, we think of that as a memory trace. So that sort of might have, and it has lots of components to it. So it might have a visual component, it might have a smell component, it might have a noise component, but in most memories, if not all memories, have an emotional component to them as well. So really thinking that this isn't just about the memories, actually, it isn't just about the visual memory, it's about the memory trace in that sense, and how we sort of unpack that becomes really interesting. The models that we've sort of used to sort of unpack that take this idea of a memory trace and really think about what can we do with those. What can we do? We can get into the sort of like details, if you wish, about what that actually looks like, and thinking about how our models can actually help us. What we do is we take a mathematical model, or even just a conceptual model, and really think about how can we use that to describe a memory process. So we get an experience that sort of like gives rise to a short-term memory. It moves into long-term memory and gets what we call consolidated. It gets sort of like repeatedly sort of like reinforced within our brains, so it becomes a long-term memory. And we think we have that. We all know. Everybody will say, "Oh, what was your first memory?" And you can tell me what your first memory was, and you think, actually, that minute's brought back to mind. You've recalled it, and then it'll go back. It'll get reset. It'll get reconsolidated. So is that reactivation, reconsolidation, that recall reconsolidation becomes really important in sort of like us understanding that, and our models and our math models help us understand that.
Yeah, wonderful. So what does the mathematical model add to this that clinical observation alone cannot.
Yeah.
Like, what does the model see that a clinician, watching patients wouldn't? And does it suggest anything about, what kind of structured activity the brain
Yeah.
might naturally use to process difficult experience?
Yeah, no, that's a good question. Thank you. So, in the study that we've recently published, what we did is we worked with a set of healthcare professionals who have traumatic memory, and using the sort of intervention, the sort of this competing task intervention to sort of like to work through how that might work. And one of the things that our math models told us was that it really depends on, as I said, there's a two-step process in this. One is that you have to recall that memory in some way, and that has to be, and we use reminder cues for that. So there's like, so like thinking that actually you've got to bring that memory back into working memory, and then you've got to compete it against the task memory. So it's consolidated, it's sitting there.
Okay.
It may flash back in it, so like in an involuntary way, but for this to work, we have to actually bring it back to mind. So what our math models told us is that recall cue, if it's too strong, will mean that actually the intervention that you would then do would not be as successful. So that was a prediction that we had from the maths that you may not necessarily see clinically. Actually, sort of like, while there's definitely a sort of like that it was known that using this recall was really important to bring that memory back bring that intrusive memory, that trauma memory back into mind, and then you can sort of like interact, you can then compete it against the task. It's the vividness of that recall that we identified in our math model. And then with the recent study, the study was to look at the efficacy and the effectiveness of the intervention, one of the things that we were able to do with the people involved in this, that they were recording and rescoring how vivid these recall memories were. As these memories came back to mind, how vivid they were. We were able to show that actually the more vivid they had these recall memories, the less effective the intervention was. And that was a prediction that we had from our math models, basically. So that was pretty cool. That was pretty, sort of like a nice way in which we get to understand sort of like the interplay between the vividness and that. With a trauma memory, that obviously comes, as I said, that trace has emotion attached with it as well. So if you're bringing back something that's traumatic to mind, it's not just the visual component, it's the emotional component as well that comes along with that. So then being able to sort of like, use that activity, understanding that detail of what our brains do with memories in that sense becomes really important. And thinking that, being able to process these difficult experiences requires us to actually be able to sort of like, if we want to be able to intervene in these, is actually thinking that actually they need to be brought back to mind, but they can't be so strong, because actually then that stops you being able, it just overwhelms your working memory and stops you doing anything else, because you become anxious and distressed and difficult to be able to sort of like take that any further forward anymore, basically. So yeah, it was a good prediction from the maths in that sense. Again, relied on us having a conceptual framework for how these memories work. So going back from this consolidated state to this recalled state, to then how that plays out. And it's this step that you just need to do. It's just, it needs to be triggered. It needs to be sort of like recalled in a way, but not too strong. It's like that Goldilocks thing, basically. Just right. Yeah.
Yeah. I'm just curious about your observation, if you have any in this area. Like, there are different kind of ethnic groups in United Kingdom, obviously in London,
Yeah.
and like if you look at South Asian groups, they're more family oriented. A lot of people are
Yeah.
together. So how, and maybe unfortunately some Western societies, like people tend to live alone and more like lonely life.
Yeah.
So how much is the impact of trauma and memory in that diverse groups? Have you ever have any experience there?
Yeah.
Does it
No,
create any difference?
it's interesting. So we think it should work anywhere. That's the thing. It should, and actually, in the study that we've looked at, we didn't separate out. In the studies that we've done, we haven't necessarily separated out by ethnic group. What we've separated it more about is whether it's acute or chronic trauma. Whether it's not in the recent study. The recent study was with healthcare professionals who'd experienced traumatic experiences during the COVID pandemic, working in hospitals. So that's like 5 or 6 years ago. So that becomes chronic in that. So those memories are in long term. They've been consolidated. They're sitting there in long term memory. We've done work with people who are more acute. So women who've had difficult childbirth, or people who've experienced road traffic accidents, and in that acute sense. And actually, the intervention works across all of these groups. brains are the same in individuals. Brains are the same everywhere in that sense, right? And then it's like, so in that sense, because this is, because we're looking at individual and how an individual responds to this, it should work. What you're talking about more is about the social support that people may have
Yeah.
around that, and in helping them deal with trauma, and that's a different issue in that sense, right? So yeah, well, we haven't necessarily looked at that, but it would be very cool to be able to think about that as an additional component to this sort of thing. And one of the things we're working towards, and in some of these studies where in all of the studies we've had so far, there's been a guide in that sense, right? So what that means is there's a sort of like a researcher or a clinician sitting with the participant, either just to tell them how to do the intervention in that sense and how it will work, and using all of those sort of like explaining out what how you need to do the recall, how you do the intervention, and just thinking through how that works. And that's always, we call them guided sessions. What we really like to be able to do is actually just to have a set of instructions that people are able to follow. It's like you would do if you have a headache in that sense, and you're just like, well, yeah, and being able to do it. And then it's just that. So we're not there yet at all, basically, but that's where we would like to be able to get to.
When people sometimes have like negative memory of some horrible experience of their life, right? So how people can like understand, okay, this is just like panicking. This is just amygdala talking, right?
Yeah.
Not my prefrontal cortex, which takes a little bit more time than amygdala in responding to these things. Like how according to you, I mean, if you have any idea or any opinion on this, people can train themselves to keep their nerves on, right? If they have some traumatic experience.
Yeah, that's right. I mean, it's different, I think in many ways with the stuff that we've been working with, these are involuntary intrusive memories in that sense, right? So you've experienced a trauma event and it's coming, just unbidden into our minds. We get, we always get those deja vu moments in that sense. Oh, I've been here before, or something flashes into our minds, and that, it's like that just happens that's just our brains, just our subconsciousness in our brains just working in that way. These are really, it's like separating out what is just day-to-day life activity in that sense, right, versus what is actually more traumatic and debilitating. And one of the things that we've looked at, one of the things that so like in the studies that we've done and the research that we've done, is actually recruiting people who have a number of these intrusive memories, like so maybe 3 a day or 4 a day or 5 a day, and that's quite a lot basically if you're getting these things that where coming in. So we may all think, you can think, oh, that was a bit of a difficult situation, and then it comes to mind and it goes away. It's actually something that's actually can start to sort of like be debilitating in that sense, and then actually stop people being able to sort of like do their day-to-day activity, rather than just, oh, it's just a life thing in that sense. So but in terms of sort of like thinking about how we do, it's like how one of the things is, as I said, we talked about the sort of like the brain is a finite space. It's like how you deal with those sorts of memories, how you deal with those things. It's just having sort of like coping patterns in space in place in that sense, right? So important to sort of like manage that headspace in the right way. Well, this is different than that, right? This is really quite a different sort of like idea, sort of like a thing that people experience principally after trauma.
So a lot of memory that's associated with a trauma, particular type of trauma, right? Obviously hippocampus has a lot of like database there, right? So whenever we experience some sort of a trauma from a memory, right, is all the information like real? Are we getting like only 50% of it?
Oh,
right?
Yeah, that's right. It's an interesting question, right? It's like, it goes back to that memory trace thing, all right? And I can ask you what your first memory was, and I know what my I can tell, a first memory or an early memory in my life, right? And I can bring that back to mind, and I can say, oh, this is what my first memory was, right? But then you might embellish that, or you might alter it. So like, I can, I know, well, my first memory was giving out biscuits at kindergarten, right? And I think, oh, it was a beautiful day, and it was in this room, and I know it was in this room, that I can tell you. But whether it was a beautiful day, whether I was wearing a green jumper, whether I was giving out biscuits, is a whole different sort. So how much we bring, when we bring a memory back to mind, we sort of like it's really cool, in the sense that they are interesting because they're labile in that sense. We have memories. We do have memories. Obviously, we have
Yeah.
memories, but what they're, and that is a representation of an event in the past in that sense. But how accurate it is and how continues to be a true representation of the event is different. And it actually comes down to this sort of thing where the trace is built up of not just the visual component or the auditory noise component. It's actually built up about the emotional component, right? So you can say, so if there's an emotion attached to a memory, so like it's very, it gets sort of rooted, you get that sort of like, oh, that's exactly so I know exactly where I was on 9/11, right? I was, in
Mm.
Scotland trying to get a plane back to London. I know exactly where I was in that sense
Wow.
because that
Hmm.
memory is associated with a pretty emotional event in that sense, right? So they call it in the literature around they call flashbulb moments in that sense. There's something that's sort of like, there's a huge emotional component in that sense. So the people who were alive in the early 60s may be able to tell you exactly where they were when JFK was assassinated. And it's that sort of thing, right? So you can pick these critical events in that sense that then sort of like you've got that sort of memory pretty consolidated and it's pretty linked. That trace is now linked not only to the visual or the auditory, it's linked to the emotion as well.
Yeah, I think what I find fascinating that in some cultures, even if you have a lot of trauma, like social status is not that high, but people still drag on, they move on, right? They just don't sit at one place and undergo depression or what people have like a lot of ideas about. And in some culture, there's more focus on mental health, obviously in the Western
Yeah.
societies. How do
Yeah.
you see like those people who do not have access to these facilities are able to move on?
Yeah.
How they can jumpstart
Yeah.
again, even having trauma while having trauma, right?
Yeah, yeah, that's a good question, actually. Yeah, I don't have any professional experience, advice on that one. It's
Mm.
just, personal in that sense. So I think in many ways,
Yeah.
as you say, the world's a difficult place at the best of times, particularly at the
Yep.
minute. We see it. It's brought in all the time. We're an information hungry species, particularly in the 21st century. It's very different to what we were maybe 50 years ago when my parents were,
Yeah.
in that sense, and our grandparents in that sense. So, the way in which we get information, at least in the Western world, is huge in that sense. The one I love best is thinking about music, right? 50
Yep.
years ago, we were listening to things on little like vinyl discs. 100 years ago, it was
Yep.
like you had to go to a theater to listen to it. Now, you can have it on demand, right? All the time. So there's
Yep.
that puts all our headspace into us, we've got all of this stuff coming into our heads all the time. So being able to manage that, I think, is important. And, if we are using this finite resource of our brains, being able to sort of like take time out from these sorts of things is a really good, this, no screen time. It's a good thing, no screen time is quite a good thing in that sense, right? And just, thinking of that actually just, letting the brain, we sleep and we sleep for a reason. There's an evolutionary reason for sleeping in that sense, right? It's actually sort of like we can't survive without sleep. You cannot survive without sleep in that sense. It's just inbuilt into everything. Any organism has to sleep. It's about processing information. We have to be able to process that information. And our brains are wired in that way, have evolved in that way to actually need to sort of like, you've got to stop the stimuli coming in, ears, nose, and eyes in that sense, and taste, touch. You got to stop that and just let it process that sort of stuff. And, it's pretty cool what the brain can do in that sense, basically. Because if it's always on, it's always on in that sense, right? And you just give it no space to sort of like calm down in that sense. So it's really, I think, important to do that. And there's subconscious activity within our brains that we've got all of that stuff in working memory. That's the stuff that keeps us going. That's obviously keeping me talking at the minute. But there's obviously stuff going on in the back of my brain or in my brain where, in that subconscious space that's sort of operating on about, sort of like keeping me, not necessarily subconscious, but keeping me breathing and keeping my heart going. There's all that function that goes on within that. And then there's all the sort of like the actual subconscious stuff where things are being processed in a way in that sense, right? And
Yep.
then, being able to deal with that is super important in that sense. I think from a biological perspective is really interesting in that sense, right? Clearly, there's also like all the pragmatic things that we need to do to look after our headspace, but understanding why our brains have evolved like that is super. Why have we evolved to have this sort of activity in our brains? Why can we imagine, for example? Why can we do this? Or why do we have this conscious awareness where we think that actually other species be probably the only, so like, well, maybe that arrogant, let's say, with that, so maybe dolphins and octopus are equally conscious in that sense, right? But
Octopus.
but it's like, that actually we have conscious and awareness in that sense. We can understand through imagination the sort of like consequence of our actions in that sense, right? And whether we choose to use them or not becomes super, super important in that sense, right? So really interesting that, how we've, how we, so how that's evolved and being able to understand that from a biologic and a sort of like psychological perspective really sits. So I think we've lost like, in many ways in day-to-day life. I mean, as my research job, I sort of get to think about this a lot, but in the day-to-day activity, we just like, we run around in that sense and we're sort of pretty detached from that evolutionary and psychological history, and then that in that sense has got us to where we are in that where we are in that sense. So it's really, it's interesting.
Yeah, I mean, I'm just curious about this, and I mean, you can refuse to answer this if you want to, but like, there is a social memory and individual memory, right? The group memory that people, like some groups have suffered trauma, right? Like maybe the Indians were under the British rule and they have this trauma carrying on,
Yeah,
and it dilutes over the period of time. And individually, that trauma is not that much. I mean, I do not feel like a slave person or someone whose ancestors were ruled by the colonialism. I have no feeling at all. But in some groups, this kind of memory keeps on like accentuating with time, right?
yeah,
And becomes worse at individual level that may lead
yeah,
to like some violent activity or
yeah.
whatever. Like, do you have any idea about that? Like, neuroscientifically, what could be the reason for that?
That's I don't know if there's a neuroscience reason for it. It's really a cultural reason in that sense of just conveying information across generations in that sense, right? And that
Yeah.
and that becomes a difficult thing to sort of like it's just like, yeah, all of that sort of like trauma, as you say, that groups of and the social group setting just gets sort of like cascaded down through generations, and it becomes part of culture in that sense. And there's a sort of like interesting, you think about that from a neuro perspective. Well, that's then the way thinking about how evolution shapes our neural activity. So he's thinking, well, actually, how much of that is just genetic and how much of that is shaped by
Yeah.
environment? And then thinking about, in biology, we think about what we're called gene by environment interactions. Well, that's sort of like, different genes perform differently in different environments. And actually the way that our genes, not necessarily down the lineages, but, the way that we get expressed really depends on an environment that we find ourselves in. There's no reason why that concept shouldn't apply in a neurosense in that sense, so that our the way in which sort of neurons get sort of like sort of wired together is really dictated by the more they get used in that sense, right? So the more that something happens, there is like that muscle memory that emerges in that sense, right? So our neurons are very good at wiring and rewiring themselves in that sense. So you could hypothesize. I'm not saying that's with the repeated sort of like this repeated sort of like delivery of information down generations. It's sort of wiring neurons in that sort of way. So yeah, and that interaction between the environment and the neuron becomes super, super interesting in that sense. And there's a lot of work on that. There's been a lot of work over the last 30 years thinking about what people call the embodied mind in that sense, which is right. The mind isn't just separate from the body and it's different for the brain. And it's actually not just that. It's part of the environment that you experience that shapes the mind in that sense as well. And it's sort of like, so runs into all the sorts of things around sort of like that we don't necessarily experience in sort of Western culture, and actually thinking more about how this sort of like plays out in that interaction through meditation is pretty interesting. How we sort of like think about those sorts and being able to sort of like deal with that and approach that actually the environment is shaping our minds in that sense. So like it's sort of like, as I said, it's like how you manage that headspace in some sense. But that's just my personal view,
Yeah,
obviously.
fascinating.
No research on that one, I'm afraid. No
I think
maths on that one yet either.
But I think fascinating some cultures how they restart after a trauma, like Germany after World War II, right?
Yeah,
Technological behemoth. Japan,
yeah,
look at them,
yeah,
like after 20 years of World War II,
yeah,
right? And just
yeah,
rose up,
yeah. No, it's
became like this
you know,
huge country. And
yeah, it's whether it's collective culture or collective trauma or individual trauma in that sense, right? And how the collective then manages that transition out of, the horrors of war into sort of like, times of peace in that sense. And it's really, it's like individuals may still carry that trauma very much so, and it's a very individual thing in that sense, but actually at a at a cultural level, things, improve or improved. Obviously, as you said, how Germany and Japan moved out of that space after the Second World War is just, is a cultural thing in that sense, right? And just, yeah, yeah, yeah,
yeah, I was just listening to some political scientists and said the next powers emerging again would be Germany and Japan, because Japan has done it so many times. The Meiji Revolution, like, they like counted Mongols twice when it was just a feudal country. Like it's just the national character and that
yeah,
collective memory of just fighting back.
yeah,
It's just brilliant.
yeah, no,
So I'm just gonna come back to your thesis work. Like, so why has the brain built such a vivid, resource-intensive, stimulation system in the first place? And what was it selected for? And what does the answer tell us about the brain expects to be doing
yeah, no,
with that system on a regular basis?
yeah, no, that's a good question as well, actually. So why is our brain the way it is? Obviously, it's shaped by evolution. It can't be, obviously I'm a biologist, so, yeah, it can't be magic in that sense, right? I think of this, so that it has to be organized in some way because I'm a biologist, and it does. And I think it's interesting. So, why is it the way it is? Well, I think I would argue that all species have to make decisions. Whatever you are, you have to make a decision in that sense, right? So even if you're a
Yep.
bacteria, you've got to decide, actually to
Yep.
do this rather than that. And that actually is grown out of all that decision making process, right? So, and then you can think about obviously deciding, on an individual, I've got to forage, I've got to go find food, or I've got to
Yep.
sleep, or I've got to find a mate. Those are decisions that have to be
Mhm.
made. So we've got to this point now where thinking about the evolution of that. So that's increasing that has to rely on increasing neurocomplexities in that sense. So neurons wiring together into hubs, into different regions of our brain. As you said, the hip forming what we would taxonomically now call the hippocampus or the
Yep.
visual cortex or whatever it is in that. So they all have those, but they're just, in that sense, they're just ways, and we've just used those to sort of help us classify out this grey matter in our head. But from an evolutionary perspective, you have these sorts of things which you have these neural centers or neural activities that need to connect, they need to talk to each other. The more complexity you get, the more things you can start to do. We see that through the emergence of life across the planet over the last 4 billion years or so. So that's pretty interesting. So then we get to this point. Now we get to a situation that we look at the hominids. So we look at our closest hominid relatives, so the Neanderthals in that sense. We say, how do the brains differ?
Yep.
Well, actually, in terms of size, not that much, but in terms of architecture, quite a lot. So Neanderthals had much more investment in the frontal cortex. We've put, as I said, put much more into our visual cortex. So that bit at the back of our brain. So there's been a shift, even in that space of time over the last, whatever, million years or so, whatever it is in that sense, just thinking that actually investment in visual activity compared to stuff to do with our frontal cortex becomes really important. So we now we were able to sort of like, I think really cool is just like, it's a little bit sort of like in the circle. We're talking about imagination by imagining imagination. So it gets really rich, deep philosophical conversations about that. But we are able to do that, right? We're able to sort of like generate these ideas and hypotheses about why that's the case. And we now have this we're a very visual species in that sense, right? Compared to others. And we use vision and I'd say more than sound in that sense, or sound travels over longer distances. Our ears are developed for that, but our vision is one of those things that we invest in. And actually, when we talk more about the mind's eye than we ever talk about the mind's ear in that sense, right? So we bring things back to mind, and when we bring things back to mind, they're visual in that sense, and we bring things back in a vivid or a non-vivid way. We were able to do that. Sounds are different. You have those, what they call them, earworms. That you get those tunes that just stay in your heads. Those are a bit like intrusive memories. They're intrusive sounds in that sense, right? So our brains are wired up in unique ways to deal with these sorts of things. But I think that is an evolutionary thing which has just led to, increasing neural complexity in that sense. And whether this, is a piece of work that we've got a bit of research work at the minute looking to understand how those systems might have evolved. And it turns out once you've got to a level of neural complexity, then actually there isn't a single way of solving the next problem. Basically, it becomes a sort of like lots of different ways for solving out how you create these systems. But we think that being visual and having vivid and mental imagery is at the root of this in that sense. So being able to imagine, so being able to use mental images to imagine, is important in that sense, right? So it's like, can you imagine it? It's like, I ask people and I do this sort of experiment on myself. It's like, can I smell bread? Can I imagine the smell of bread, right? So if I imagine the smell of bread, I can't hold that smell. If I think hard, I think I can smell, can think, I can feel, or whatever, smell. In my mind, my mind knows what bread smells like. But the first thing that comes into my head is a picture of a loaf of bread, right? So it's really interesting, yeah? It's able to do something, in that sense. Maybe it's different with different sort of modalities, if you're using your ears in that sense. But if you're thinking about, visualizing a smell, I mean, that's a bit of a sort of like oxymoron in that sense. So it's interesting, right? But our brains have just evolved to do that. And why, and think, why are we good at imagining? Why do we have trauma memory in that sense is an interesting one as well. So, I always use that idea that, okay, having trauma memories are, probably an important thing as a survival instinct, right? So actually being scared of lions is probably a good thing because actually means I'm not going to get eaten by a lion. And the thing that, and that's probably good to actually have that. But what you don't want is you want to have the memory, but not the emotion. You want to know that actually to be afraid of lion, but not to be so traumatized by it that you sort of like stand still and you're sort of like rabbit in headlights or things, and then you get eaten. So that's the issue, in thinking about this sort of work we've been doing about trauma memories has to have some, these involuntary intrusive memories must have to have some survival instinct in that sense, right? They just, they're costly to produce. If things are costly to produce, they wouldn't happen. And understanding them becomes, being able to understand their evolutionary importance. And then actually in the 21st century, we want to be able to sort of deal with all of the horrors that trauma then brings with that. So, it's no longer lions. It's obviously much more horrible than that. And actually the important thing about being able to deal with these memories is that they are precursors to other mental health disorders that we want to be able to manage in that sense. One of the biggest ones is PTSD. So these are a pretty strong indication of if you're not dealing with them in as I said it earlier, in that frequent basis where you've got 3, 4, 5 a day, that's a pretty sort of telling symptom that you're on the track to PTSD, and being able to deal with those becomes really important.
But I think it's crazy that how some people are able to use negative energy, like negative memories, positively in order to grow in career, like leadership, like we study in management, like how some leaders talk about competition all the time, so they're motivated and charge at extra charge, right? And the panic that you're talking about is actually the amygdala, overworking, and it saved us from the lions in savannah, like
exactly,
when we were early men. But the problem is that these days, whenever you lose some followers on Instagram, people start panicking. Okay, I'm gone now. But that's also has like a lot of negative ramification on cardiovascular system, right? Your blood pressure is rising, and you're always panicky.
That's the emotion bit of that memory, right? It's that's what So
exactly.
With wearables these days, you can put things on your head, you can put things on your fingers, you can put things on and you can see how if you get stimulated by a memory, not only does it just come back to mind in a vision, through a visual image, it's actually doing something to your skin conductance and your heart rate and your blood pressure. So that's it. That's is all of that memory trace. And what you're trying to do with these interventions is to sort of is to dull that, not to it. So also in the literature, there's a lot in the literature about calling what they call memory extinction. And that's sort of to my mind, that's trying to make it go away forever. And you don't want to make memories extinct, right? What you want to do is to sort of rearrange them in a little way, right? Make them, less intrusive and less emotional content with them, basically. So actually, you do remember it. It's important to remember it, but actually being able to, but it is then no longer debilitating in that sense, right? It doesn't sort of freeze you and raise your blood pressure and make you super anxious in that sense. So it is all of that. That memory is actually, as I said, is a complex syndrome of things in that sense, right?
Yeah. You talked about how we when we think of a loaf of bread, we visualize first and we think of the smell, right?
Yeah.
That comes
Well,
later.
that's
It's a
me. I don't
stepwise
know how other
process.
people do that. I can only talk for me, basically, right?
No, I was thinking about, because I'm into perfumes, and whenever you use a perfume with a ocean, fragrance, you think of the ocean first, then you think of the smell,
Yeah, it's
right?
cool.
That's
Yeah,
fascinating.
yeah.
But my question to you is, there's a lot of work done in robotics these days, which is increasing your senses, like your vision, your perception of audition, your taste. I'm thinking, what would happen if we maximize all of this
Oh my
using
goodness.
technology?
Oh my goodness.
How would the brain
Oh my
process
goodness.
information then,
Yeah,
right?
yeah. Well, our brain is
I think it's coming.
it's like, yeah,
It's
it's
coming.
coming, right? So, our brains are wired up in a way that sort of like, it deals with our physiology in that sense, right? It's, it's a pretty amazing organ in our heads that's sort of like controlling all of our function in that sense. And we're, and in biology, you want things to be in that nice homeostatic state. Otherwise, you've got but if you're now elevating that and everything's on, one of the things from my math worlds is that negative feedback is really important. So, not letting things escalate. You actually have to have things that sort of like feedback to sort of like control those sorts of things becomes really important. Because if everything's on, then you end up being in a different space. So it's interesting, right? Yeah, I just from the readings around this, can if you on your going back down to the real basics of this, our neurons have a particular type of firing pattern. So we move, let's say, sodium potassium across a membrane, that actually sparks off, it depolarizes and resets, and that has a particular type of electrical conductance, right? If you alter that in any way, you're changing the way the neuron's being stimulated, and you're going to get a different amount of input into your brain of that sense. So, we can do this. There's lots of, we can read. I've never have and never will do this sort of stuff where you can take whatever, some sort of illicit substance, and it could sort of do things to your minds in that sense. And that, what you're doing, you're actually changing the conductance patterns across your neurons. So like these neurotransmitters are working in different ways. You're messing with your serotonin and your dopamine in different ways, and that sort of then stimulates your brain in different ways. And we know what that can do. We hear, you read, or you've experienced what that can do. So now you're going to wire everything up to a greater degree, right? What's it going to do? Well, I think we probably have the foresight to understand that it's going to wire us up and make us, it's going to put us into essentially a different reality in that sense, right? Well, the reality your experience to me that I'm experiencing now are different. We're on this podcast, I can see you, but actually there are subtly different things that we are picking up, right, in that sense. And our neurons our brains or minds are processing all of that, and then we've wired this up. We just sort of like, now we're doing stuff to neurons in that sense, and that's going to change the way in which we experience this stuff. And we know that works. We know, even single neuron, sort of like stimulation, so like using convulsive therapies to treat people with epilepsy or schizophrenia or whatever it might be. And back in the day, what they're doing, they're just trying to rewire the brain in that sense, and just trying to sort of like change the electrical conductance that happens with the way these neurons fire. So that becomes really important to understand. We better understand what that's going to do. As you sort of like, as you crank it up, it's not actually whether it's affecting vision or hearing or smell. It doesn't matter. You're cranking up the activity in the neurons around that. So we better understand what it's going to do in that sense, because then if it's always on, as I said, we need to sleep, we need to process this information. You can't have it always on in that sense, right? We need to let our neurons calm down. They know they like to chatter, but it's good to let them be quiet sometimes too.
Yeah, or I am thinking in terms of social implications, like, when we are so focused, we just want to work, right? We just want to focus on the work. If you're on all the time, we just don't want to talk to people, right? I just want to code all day. I just want to do something all day.
Right. Yeah.
It's just going to also kill social relations,
Yeah,
right?
that's right.
Fascinating.
Yeah, no, that's it. Then that, again, from that social perspective, that's important in that sense, right? You can't always be on in that sense, right? You can't always be on.
Exactly.
You can't, whatever it is, you just can't do it continuously. You've got, there's a finite amount of time, and we need to sort of like partition it. It's like, whether we forage, go for food, sleep, find a mate, whatever it is, go to the cinema, whatever. We need to, that sort of stuff is important. It's important, as it's important from a social perspective. In that sense, we are a very social species in that sense, but understanding, the sort of like, that's important for our minds and our brains, and to actually, deal with this. And it's, you can't have on one thing all the time, basically, because it would just, it would destroy it. It would destroy it. Yeah. Yeah.
Absolutely.
Yeah. And it's interesting, right? You think about,
Who?
sorry, you think about this from a,
Yeah.
sorry,
Sorry. Yes.
sorry. So you think about this from
Yeah.
a
Please continue.
humanity perspective, right? We're shaped in a way, in many ways, by the way those neurons fire, the particular sort of like characteristic that neuron firing has. You change it in some way, and there's a question back to you in that sense. Does that really change the fundamentals of what it is to be human in that sense? Right?
I absolutely think so. And AI is replacing communities. AI is creating, people are talking to AI. AI is their friend now. It's giving them positive feedback and how amazing they are.
Yeah.
They don't want to talk to people.
Yeah.
And I was listening to this Chinese philosopher who was saying, people just cannot believe that AI is not real.
Yeah.
They just don't think it's real.
Yeah.
They think it's actually real. Like,
Yeah, and where's
it's
that?
actually someone talking
And
to them, right?
those large language models that that are all built on information that we've put out there, right? So in many ways, it's just reflecting, in some sense, things that we already, we know in that sense. But you're right, so it's like, but it's interesting. It's an interesting space to be in, and I think actually, again, no screen time is a good thing, right? I think actually, particularly ensuring that we still maintain the roots that we have in that sense with our families and friends, and don't involve computers all the time, has got to be a good thing, right? Our neurons can't be, stimulating our neurons in diverse ways at a level that maintains our homeostasis is a good thing to do. Yeah.
I remember as a kid in the pre-internet age, we used to sit together, play board games with each other, crack jokes. I think that has to be brought back. Those the group ritual that you can do together, like every day from 7 p.m. to 8 p.m. or something like that. Make that routine.
Yeah, no, it's interesting, so it's very easy, and actually, obviously, just to drop down the internet rabbit hole or the infinite squirrel rabbit hole, and just, with your social media and go on forever in that sense. But, it's just, it's the world. And again, it goes back to what we were just saying, about this need for information. We have this insatiable need for information, and I don't know where that comes from, but in the sense that as said, we just want it all the time, basically, and it's like there's work on that sort of like gratification that you get, and when you'll know this, there's sort of like when it's like when you can't get it, it's like an addiction in that sense, right? And obviously that's done things to our brain, and these things have been designed to do that. Those apps have been designed to suck the thing that's most valuable for you, your time, and suck it away from you, right? And that's what they do. They're all built to do that, right? For whatever reason, for whatever whether it's marketing or games or, social media, they want your time, and that's the most precious thing you have. So, you better want to think about how to use it the best way you want to do it in that sense, right? So, yeah. So as you said, thinking about, doing, sorry.
No, please continue.
Sorry.
No, I was just thinking like maybe that desire to get infinite information or more information than others started with Neolithic, when the agricultural revolution started and we started building societies. Then after building society, we have to be better than the others. This competition, this is ingrained in us. Like we have to know more than the other person. So we win. I want to be a winner.
Yeah, right. Yeah. I mean, that's just, and in some sense, there is that, we want to know more, but actually, what's it serving in that sense? And what are you competing against? And what are you competing for in that sense, right? Just, it's just like, so it's an interesting one in that sense. So, yeah. Oh, it's interesting.
I think societies are reward winners. Like, look at Indian society, so much cramming of books. You have to remember rote memory, everything. Same in China. But in Western society, the competition is different. The winners are different. The more money you make in the United States, the more respected you are. It's a crazy society,
system, right?
But Britain is on the different structure, structured so differently.
Yeah.
It's fascinating. Okay, my last question to you is, if you could design the thing that would actually work, not the trial you can fund, but the infrastructure that gave people ongoing structured access to practices their brain evolved to need, what would it look like? And what would it have to do that almost nothing currently does? And what would we stop calling a mental health crisis if it existed?
Yeah, that's a good question. I'm not sure I have an answer. And what would I like to do? Obviously, I think, again, one of the things that we've demonstrated is how simple little things, doing gameplay in that sense and using these interventions in a particular way can help. Being able to sort of like, I guess, just making sure, research can continue to find these simple solutions to mental health is just the space to be in that sense, right? So we think we've got an approach that might work in that sense. What we would like to be able to do is to make it as accessible, as widely accessible as possible in that sense. So making sure people understand how to use that safely in that sense, because it isn't that it has, like anything, it has to be used in the right sort of way. So what would it so I think that is just being able to sort of like, I think, understand our brains in that sense in a richer way. So trying to answer your question. So what would a technology look like? Well, actually, the first thing we need to do is like, well, how is this working? And in many ways, we know more about the surface of the moon than we do about what's happening in our heads in that sense, right? So I think in many ways there's that. There's a fundamental research that needs to continue on that sort of space. And from that fundamental research, who knows where the next translational innovation will come from in that sense. But if it helped, just being able to sort of like deal with this sort of like the mental health crisis that we have across the planet, I think is just, something that this requires us to understand both things at the neuro level, at the sort of neurodynamic level, at the sort of like the psychological cognitive level in that sense, to be able to sort of like bring those two things together. I don't know what that looks like. I wish I did, because then that would be great, wouldn't it? And just to have all of that. But I think one thing we've found through all the work we've been doing is that understanding these things at different levels of organization, so from the neuro and from the cognitive, from the psychological and the psychiatric, it becomes really important to have that together, all of that linked together, so we are able to sort of like, do the best we can at sort of like developing these sort of technologies. Lots of space to do stuff in, and lots of, as you said, lots of need in this sense, unmet need in this sense, where we need these sorts of interventions for mental health.
Yeah, and I think just to end it, maybe one thing we can do is learn from each other, like from different cultures, how people are processing different kinds of trauma. Like, if your pet dies in Indonesia, they have this like big ceremony. So you're actually able to convince yourself, okay, my pet is in a good place now. Otherwise, because I'm still suffering from my pet loss, who died like 10 years ago, right?
Yeah.
That memory is still there.
Yeah.
So rather than just like being in a single room and just like, like being sad about it, we can maybe learn from different cultures.
Definitely. Yeah, definitely learning from each other, basically. Not beating each other up would be a grand thing. Yeah.
Absolutely.
Absolutely.
So, Professor Michael,
thank you.
Thanks for your time. I mean, I know you must be very, very busy.
Yeah.
So, I mean, thanks for coming to the podcast. Maybe we'll talk
Yeah,
again.
it'll be lovely.
If
It's great.
free
Thank you.
sometime.
Thank you for your time. Been great to talk to you. Yeah, enjoy the rest of your day. Take care.
Okay,
Thank
sir.
you. Bye-bye.
Bye. Bye.